Assalamualaikum warahmatullahi wabarakatuh. My name is SYED ILHAM. So today I'll be presenting about Lab 4, which is Laplace transform. So for Lab 4, we'll be doing Laplace transform and inverse Laplace transform in MATLAB and also partial fraction expansion. So for partial fraction expansion, we will be able to study about poles and zeros from the partial fraction. So other than that, we'll be plotting the graph for the zeros and poles using MATLAB. So for part 1, I'll be doing question 4.1, 4.2 and 4.3 uh, through MATLAB. So okay, let's start from 4.1. It asks us to get the Laplace transform and inverse Laplace transform based on the equation. So for question A, yt equal to 3t sin 5t. So it is in time domain, so we're supposed to change it to S domain. So I have already done it in MATLAB. So for the comments, we use sims t, which is to symbolize the variable. So for this example, we use t. For time domain, we use t for sims, and then we use the command Laplace to to Laplace the equation. So after we run, we get so this is the equation that we want to Laplace. So this is the equation after we Laplace we do Laplace. So we get 30s over s square plus 25 square. So if we look at the table, so for the table, so we look at here, t sin 80. So we get 2as s square plus a square. So our a is 5, so we get 5 times 2, which is 10. So 10 times with 3 here, we get 30s. So for the below part is the same. We get s square plus a square, which is 25, and then square the bracket. So that's for question A. For question B, yt equals to 8 exponent negative 3t. So so it's the same method. We just change the equation. So we get 8 over s plus 3 for the Laplace for this equation. So if you can see exponent at, we get 1 over s minus a. So a here is negative 3, so we get positive 3 here. And then we just multiply with the 8 in front. So we get 8 over s plus 3. So next question is still a time domain function. Same as this, but this time we use pretty just to pretty is used to rearrange the answer to a better form, to a much simpler form for us to read. So we get 4 over s minus 5 over s squared plus 4 over s cubed. So for this one, so this is the product for pretty after we done so this is fs Laplace, the normal one. So after we do pretty, it will become like this, a simpler version for us to read. So for the next question, okay, for this one, the function is in s domain, so we are supposed to change from s domain to time domain. So for time domain, so this time we change the sims to s, and we change the from Laplace to inverse Laplace because we are changing from S domain to time domain. So we're using inverse Laplace. So after we run, we get from 4 over S plus 3, we get exponent negative 3 times 4. So as we know from the table, so S plus 3, if we remove this 4, if we move it outside, it becomes 1 over S plus 3. So 1 over S minus A. So we just change this positive 3 to negative 3 to get it into this form, and then we can just apply the table from the table. So we get 1 over S minus 3, so it becomes exponent negative 3t. So exponent negative 3t times with the 4 we brought out just now. So next question is fs 4 over s plus 3 square. So this is still from s domain to time domain, so it's still the same method. This time we have s plus 3 square. So this one, if we look at the table, if we see so t, so this one we will be using this one. So just like the previous method, we just bring out the 4 and we get the we get the formula for this one. So we just inverse from this side to this side. So we get t times exponent negative 3t times with the 4 we brought out. So next is okay, still the same, time s domain to time domain. Okay, for this one actually we're supposed to get if we look here, we're not supposed to get 27, we're supposed to get over 9. If based on calculation, we're supposed to get over 9, but after we do the pretty command, we get the correct answer, which is exponent negative 2t cos 90 and minus sine minus 2 over 27 sine 90 times with 3. So after we do pretty, we get the correct answer. If we divide the equation by 3, then we're supposed to get 2 over 27. If we do calculation, we're supposed to get 2 over 9. So I'm not sure why MATLAB ignore this part. We're supposed to get negative 9. If we divide by 3, then we get 2 over 27 times sine 90. So okay, next we'll be going for question 4.2. So 4.2 is just we get the partial fraction from the equation, from the S domain equation. So okay, so this is for question A, which is s square minus 16 s cubed plus 8s square plus 24s plus 32. So okay, for this one, we'll be declaring uh, the numerator and denominator first by using matrix. So for this one, we have three numbers in the matrix. So this will be the number without the power of s, without s. So it increases. So this one is just a normal number. this one will be supposed to be the next with uh, next number with s, and this one will be s square. So same same method applies to the denominator. So this will be just 32, then 24s, 8s square, and s cube. So after we do tf, so tf is transfer function. So transfer function, uh, you will do the you will rearrange our numerator and denominator into this form. So as you can see, so s square, this is s square, so there is no s, so 0, so negative 16, this is negative 16. So same for denominator, so this is s cube, then s square, 24s, and 32. So okay, so this is the full equation. So after that we do residue, uh, we do residue to get the polynomial functions for the transfer function. Then after that we just do zpk and get the polynomial function, the polynomial function, the partial function. So this is the partial function after we uh, after we uh, do the commands. This is the partial fractions. So next we'll be doing b. So for b, I expanded the denominator, so I multiplied the the numbers in the bracket with the s cube, so we get s power of 5 plus 2 s power of 4 plus 10 s power of 3. So in MATLAB, so okay, this is the 2 above, the numerator. So this is s power of 5, s power of 4, s power of 3, and this is supposed to be s square, s, and normal number. So after we run, we'll be getting, see, this is the equation. So as you can see, the equation is already in partial partial fraction form. That's why we get the same as the equation. So next question will be, so 3s plus 2 over s square plus 4s plus 5. So okay, so after we run, we're supposed to get the same. So 3s plus 2, s square plus 4s plus 5. So we get the same equation after we put the numerator and denominator in the matrix. Then after that we get the partial function, the partial fraction. So this partial fraction is used for the next part of the question, which is question 4.3. So partial fraction is very important for us to do poles and zeros later on. So okay, for question 4.3, it asks us to obtain the poles and zeros and plot the system using poles and zeros. So okay, for this one, so we have s cube plus 1 over s power 4 plus 2s squared plus 1. So the same method as before, we find the partial fraction. So after we run, we're supposed to get the partial fraction and a graph for the poles and zeros. So this is the magnitude graph, and this will be poles and zeros. So for poles and zeros, so for zeros will be depending on the numerator of the system, And for poles, we'll be checking the numerator of the system. So only the variable with s will be counted as zeros. We'll be looking at the variables with s. So if for this one, if we open, we do a partial fraction again for this one, we will get something like this. So if we take this, s plus 1 will become equal to 0, then we open, then we just expand, so we get the poles around. So there's a real number and imaginary number for zeros. So the circles are zeros and x are the poles. So next we'll be doing question 4b. So 4b is the same except for the zeros. As you can see, this one doesn't have any variable s. So if we run for this one, so this is the magnitude and this is the 0 pole. So as you can see, we have no zero output, since the top the numerator does not have any s variables, so we do not get any output from here. So next will be for this one, 4s square plus 6 over s cube plus s square minus 2. So same method, you just fill in the numerator and denominator and transform function, and get the partial fraction. So the magnitude and the zeros. So as you can see, okay, for zeros, so it has imaginary number, because if we try to open up this bracket, this equation, the value of s will be the value of zeros will have imaginary and real number. So for real number, for zeros we have -0 and 1.22 for imaginary. So the other one is supposed to be vice versa. So I mean vice versa in terms of positivity and negativity. So for poles, it's also the same. So we have a negative real and imaginary, and a positive imaginary. Only the imaginary is has the opposite positive or negative for poles. If we have imaginary and real. So as you can see, this one is just from so this one only has one pole. So this one is from here, s minus 1. So s minus 1, so we get pole equals to 1. S minus 1 equals to 0, so s equals to 1. So the pole is equal to 1. That's how we get the poles and zeros for from the equation. So I think that's all for part 1. So after this we'll be continuing with part 2, which is question 4.4. So for question 4.4, I'll be doing a manual calculation for the Laplace transform. So I think that's all. Thank you for watching my video. Assalamualaikum warahmatullahi wabarakatuh. So today we continuing for part 2 of the lab 4 assignment. So for part 2 we'll be doing question 4.4 through calculation. So for for this one is question A. So question A, we have s plus 3 s cubed plus 7s squared plus 10s. So first of all, we have to expand this equation from, so this part is actually from s cubed plus 7s squared plus 10s. We expand so we can do partial fraction better. So after we expand, we can do partial fraction. So this is the partial fraction form. So a over s, so b over s plus 5 and c over s plus 2. So after that, we'll be multiplying each of the each of the variables with this s s times s plus 5 times s plus 2. We'll be multiplying this with each of the variables, so we get this equation. So after we get this equation, we're supposed to we proceed by using the elimination method. So elimination method is to find one of the variables, we eliminate the other variables. So for the blue one, so this one, the blue one, we'll be finding b. So for b, we eliminate uh, other variables except for b. So we will be eliminating a and c. So to eliminate a and c, we just let s equals to -5. This will uh, make, so a times s plus 5. So when s equals to -5, so -5 plus 5 is equal to 0. So here will become 0. So as you can see, a equals to a times 0, and c will also times with 0. So we will remain only with b in the end. So as you can see, we get -2 equals to 15b. So b is equal to -2 over 5. So for the next one, we'll be finding c. So same method, the method of elimination. So to find c, we have to eliminate a and b. So to eliminate a and b, we just put in -2, s as -2. So when we let s equal to -2, every s variable will become -2. So here also will become -2. So we get, so a times with 3 and 0, so becomes 0. B times with -2 and 0 becomes 0. So we are only left with c. So c is equal to -2 times 3, so we get 1 over -6c. So we get c equal to -1 over 6. So this is I just copy back for my view, to simplify my view. So the red one is for a. So we just let s equal to 0, since c is times with s and b is also times with s. So by changing here to 0, we get 0 here. So we get a is equal to 3 over 10. So after that, we have gotten all the values. So after that, we take all of these values back into here. We just change the values of a, b, and c to the values we have gotten just now. So we get 3 over 10 times 1 over s, -2 over 15 times 1 over s plus 5, and -1 over 6 times 1 over s plus 2. So for each of these, we just apply the table, the Laplace table. So from Laplace table, we inverse Laplace. So 1 over s is equals to 1 if we inverse Laplace. Same goes to 1 over s plus 5. We get exponent -5t. and for 1 over s plus 2 inverse Laplace, we get exponent negative 2t. Since the this one is actually 1 over s minus a, so our a here is equal to negative 2, so that's why we get negative 2t. Same goes to s plus 5. So next we'll be doing for b. So b is already expanded, so we just straight away apply partial fraction. So sorry. Sorry, my screen disconnected. So just now, okay. So just now we apply partial fraction. So after we apply partial fraction, same method, we times with s times with s plus 20, or we can do cross multiplication. So we get this equation afterwards. So same process, we do process of elimination. So we get s is equal to 0. So to remove b, so when it's equal to 0, b equal to 0, we get a equals to 1 over 5. As same applies to b, same applies to b. So we let s equals to negative 20 since s plus 20. So negative 20 plus 20 is equal to 0. So here we apply here. So we get b is equal to 39 over 5. So same as just now, we put back the a b 39 over 5 back into this equation. See, we apply back, so we get 1 over 5, 1 times with 1 over s plus 39 over 5 times with 1 over s plus 20. So same, apply Laplace table. So for inverse, so 1 over s inverse Laplace, we get equal to 1. And for inverse Laplace, 1 over s plus 20, we get exponent negative 20t. So this one is a equals to negative 20. So to verify our answer, we can check through MATLAB. So for this is the answer for A, right? So let's try to MATLAB. So let's try to MATLAB. So this is question A. So as you can see, we get the same answer as just now. 3 over 10 times with negative 2 over 15 exponent negative 5t minus 1 over 6 exponent negative 2t. So it's the same answer. So next we'll be doing it for B. So this is for B. We get 1 over 5 plus with 39 over 5 exponent negative 2t. So it's the same answer. We get the same answer for both of the calculation. So we have verified that our answer is correct through calculation and through MATLAB. So in conclusion, what we learned from lab 4 is how to do Laplace transform and inverse Laplace transform. and through both methods of MATLAB and calculation. And next is we learn how to do partial fraction to MATLAB. So partial fraction is very important for us to find the zeros and poles, and also uh, to for calculation partial fraction is used for inverse Laplace also. So other than that, we learn how to plot the graph for zeros and poles uh, from the equation using MATLAB. So all of the objective of lab 4 is achieved through our exercises that we have done today. So I think that's all. Thank you very much for watching my video.